So today we're going to be doing another histogram on Scilab from the Open Data website. And that will be the end of the histogram insanity we have to do. Anyway, so what did we do last time? We made histograms in Excel from this website from Open Data CERN. We're going to do that again, except in Scilab. So I want you to work with one of these. For your activity, you're going to either run with the full data set, or you're going to run with one of these three runs. You can't do run zero. I'm going to demo for you, so I'm going to just do it with this one. But yeah, I would use the 14.5, I would use the full data set, because that's going to give you the best results, if you have all the results. But if you have download problems, like your connection to the downloading data is slow, you can use one of these ones. So let's try run 0. First time I've ever done run 0. But anyway, here's run 0. Show in folder. I'm going to just copy this over to my desktop, because that's where everything is. My downloads directory, put it in the desktop. Okay. Let's minimize it. There it is, popped up right here. Double click it, should open up in Excel. There's all the information. Now from last time, if you remember this, this is just where it happened. I'm going to delete all the columns. I don't need anything except the mass. And the mass is the last one. So I selected all the columns. You can just click and drag to select them all. So I'm deleting all this information. The way I delete it is I right click, go down to delete entire column. Okay. Just blasted away everything but the mass. So that is what I want to make a histogram of in Excel. But to make a histogram, you've got to have a bin range. So last time we did like, we started with like 1, 2, there's like 100, so that's way too many. I don't know why I did that. I want to go up to about 100, because that's about how much mass there is in the highest one. So I'll scroll up and just delete all these. You know what? Actually, let's just leave it. You know what will happen? Nothing. It's just shouldn't. Here, I'll just recopy it. I'm just going to recopy it. It's going to be easier this way. So I'm going to go down to about 100. You were supposed to do in the homework, you're supposed to do about 100. I'll do 104 so you can see 104. Okay, and then you go up here, create data menu, and you're supposed to install the data analysis package. If you haven't done that, look at the last video and from last time's assignment and do it. Histogram. Okay, so the input range. So this saved from the last time I did it, which is nice, but the way I would do this, I'm just going to delete all this so you can see this again. You're just going to select your data, go all the way down, but that's bin range. Let me try that again. Input range. Input range is my data. So I'm going to click here. And then instead of scrolling all the way down, just type in the last cell, which is 100,001. And then the bin range is going to be these numbers right here. So we'll just select all 104 of those. And then you want a chart output, sure, new worksheet, that's fine. Okay, so now we get a histogram that you made last time. And then you can make it bigger by just doing that. And I thought the interesting bump was right in here, which is a particle at 9 eV. I think it's called an epsilon meson if you Google it, 9 GeV. But it turns out the interesting stuff is actually happening. There's more interesting stuff happening in the 90s. You can't see this, but I was reading about the data set. And the data set has some interesting stuff. So again, when you first made a histogram, I think we used like easy histogram maker, and it didn't really have this bump in here. And so we tried to zoom in to see what was happening. But again, like, there is stuff going on here, but I can't see the shape of it. It's so little compared to these numbers. So one way I can do that is, like, if I delete these numbers, these big numbers, the other ones just go away. So you can kind of see the numbers here on this scale are getting smaller. And you can start seeing you can start seeing little things happening over here. And I'm interested to see, like, what is happening over there, right? And so I can just keep deleting these, and the numbers keep going down. So you can see, like, let's delete one more of those. You can see that there's little peaks. Maybe there's bumps over here. So I'm very interested to see if there's any sort of bump. So I'm just going to go ahead and zoom in between 85 and 100. And just, that's what I'm going to do next, just for fun. So one way I could do that is by making a new bin range. So 85, and then 85.5. And then I'm going to copy that down until I get to about 100. Right there, one more. There we go. Okay, and then I'm going to delete these other ones. That's good. Okay, so what I want to do is run a histogram for this bin range. And maybe I could have just actually typed these numbers in. I don't know if that's gonna. I think I destroyed my other bin. No, it's still there, but I've messed with it a lot. Let's make a new histogram. So, data analysis, histogram. Okay. Data's good. The bin range, I'm gonna change that. My input range is good. My bin range has changed. It's from 85 to 100, so there's less bins, but it's a different range. That looks good. So we hit OK. Got a new histogram. It looks like something went wrong. I'm going to make it bigger to see what we can see. Looks like something went horribly wrong, but it's actually doing fine. I'm just going to delete this. I just click it and hit backspace to delete the legend. But what's happening? How come I'm not seeing anything? Well, it's because it's graphing 10,000 85s. So what I need to do is just delete 85. And you see that the shape kind of pops up. Notice that there's lots of these more than 100. So if I get rid of that, it'll give me kind of a nicer graph. More than 100. So you can see here, there's some information, and I can't actually see the peak. However, if you do this activity with the full data set, you'll see a bump. I'm not convinced there's a bump anywhere in here. I need more data. So this data has, you know, it doesn't have all 100,000 of these. I just realized I'm on planet 0 here. I'm on run 0. And how much data does run 0 have? Probably only about 1,000 data points. Maybe a little more. Maybe 10,000 data points. I can do my math. So it's probably got about 10,000. I guess I can just scroll down here. Yeah, it's got 10,001 data points. So if I wanted to use the full data set, 10 times more data, I'm going to have a better understanding of what's happening. Like, how do I know if it's there? Probability, and so I need more and more data. So your assignment is to do this same thing in Excel or Scilab. I'm basically going to show you how to do it in both, so you can pick which one you want to use. So this is exactly what you want to do with the full data set, or one of the other runs if you can't download it, and you won't get bumps probably, but if you do this with the full 100,000 data points, you should see a bump somewhere in this range, and that bump corresponds to a particle. Okay, so that's interesting and fun. Let's do this in Scilab because we've done it in Excel, and this is sort of the procedure for doing it in Excel. So if you can't use Scilab for whatever reason, like you could never install it, you just hate it or whatever, and you want to do this in Excel, this is how you would do it. So just to recap the procedure here, you're going to delete everything but the mass, then you're going to make your range of data. I use 85 to 100, and I go up by half each bin number. I don't know if you saw me do that. I'll do that again. I kind of went fast through it. Basically, what you do is you type in 85 and then 85.5, and then Excel, if you drag this little box down, will see a pattern and just fill it in for you. So you do that until you get to 100 or whatever, and then you plot the histogram. Okay, so how do I do this in Scilab? Scilab's got a slightly different option for you. But here's how I would do it in Scilab. So if I start with my data, I'm going to delete everything except the, so I'm going to go ahead and delete the, I know this is sacrilege, I'm deleting my work here. Save your work, right? How do I save my work, by the way? Like, suppose this is what I want to turn in. I know, I feel like I'm beating a dead horse. That's an expression, old expression my science teacher used to teach me. You're beating a dead horse. So if I need to turn this in, like, this is what I'm turning in, right? My histogram. So remember, you can grab your little snipping tool, and it's called grab in Mac land, snipping tool in PC land, and you just grab that image, and you want to file, copy, or save it as a JPEG. I like to just copy it over to Word because, like, you have a work file. So you'll have a work file. I apologize, I don't have the work file open, but you'll have a work file, and you can just paste it in. Control V is what I did. Copy, paste into the, this is like, so this is my work. But anyway, before you delete any work, you should save your work, right? Okay, how do I do this in Scilab? Because I'm gonna, thank you. Almost done. Okay, so I'll be doing this in Scilab again. Let's go to our sheet, and I'm gonna delete these columns because I'm not actually working, so I'm gonna be totally doing this differently. So if you start with your original data set, and delete everything but the masses, this is what you want to save. So I'm going to hit File, Save. Right, that should save it to the desktop, and I should be able to import that into Scilab. So let's open up Scilab. Is this the picture of Rafa? Yes. Look, Rafa is wearing a Beamline for Schools t-shirt, because this is from CERN's Beamline. That's a Beamline where they fired the particles to get the data. Isn't that nice? All right, anyway, Scilab. So Scilab, let's open that up. And, okay, so I want to read in my CSV file. Now, I cannot just type in CSV read and then the file name. So the file name in this case is new run 2010. I'm going to click on it, B_0. So I just see it there. Capital B_0.csv. Because it says it does not exist. Some people are having this problem and they're like, I don't know what to do. It doesn't exist. I don't want to read it. Well, I'll tell you why. It's because you're in the documents folder. So if you type in the command ls, it actually shows you where you are. It shows you what you can upload. Because my videos, my pictures, my music. So if you're in documents, it's got all these other folders, right? So one hack would be to just move this into your My Documents folder, wherever it is, and it will appear there, and then you can copy and paste it. So let me try doing that. I'll just copy it, and then I'll search for My Documents. Uh-oh, there's two of them called Documents. Which one do you think it is? This one? No. I don't think, I think it's this other one, the one that's got my videos or whatever. I don't know, maybe. Sometimes, this is why I don't like using documents, because there's, like, sometimes there's more. Well, there it is. It found it. So I put it in the documents folder, and there it is. So now, when I type this in, it'll work. I'm apprehensive to hit enter, but I'm going to do it anyway. I know it's going to be bad. And the reason is, it's printing out all the numbers. And sometimes that takes a long time. When you do this with the full data set, it takes a long time. It feels like it's crashing your computer. So if you do this, and it's just loading forever, Control C. Control C. You type in Control C at the same time, like you're copying and pasting. Control C, and then it will stop printing out the numbers. Because sometimes you get caught in a loop. That happened to me. But anyway, there's my answer, right? Okay. Instead of just calling it, I'm going to give it a name. So this is called mass equals this. There you go. So I now have a variable called mass. It's 10,001. You need to make a histogram. Histogram command is histplot. And then you type in the number of bins. So I'm going to do, like, let's do 100 bins like we did in the first Excel spreadsheet. And then we're going to call the variable mass. So if I do that, here's what happens. I get a histogram just like I did in last time's activity. And you can see most stuff happens. There's a bump here at the Epsilon Meson at 9 EV. 9 GeV is this mass of the Epsilon Meson. So I'm interested in this region. How do I zoom into here with Scilab? Because that's basically where we're at. Well, there's kind of a secret, and that's called the logarithm. The logarithm is going to kind of flatten out the information. So the way you're going to do logarithm is by going up to edit, I think, edit axis properties. And you want to come over here to axis editor. And your x values are fine. There's nothing wrong with your x values. You know that the histogram starts from 0 to about 120. You know, this is the range. And these numbers are good. What's not good are these numbers. What I want to do is flatten these ones. When you do this with a full data set, these numbers are huge. They're like very large percentages. So you go over to y. The y-axis, I want to make these numbers logarithmic. So what I did was under edit, so I'm going to do this again just to show you guys again. You go under edit, graphic axis properties. You go over here to y. And you click log. You come over here. And you type in, I'm trying to figure out if this is updating in real time. Oh. And, okay, I'm having some issues here, and I think I know why. So let me just do this one more time. I'm going to normalize this first, I think is what I need to do. So let me just close the window, and when I hisplot mass, I'm going to do normalization equals %f. Okay, that's going to give me my number of counts, and so this is basically the same exact graph. The only difference is the numbers are huge. Why are the numbers huge? Because I normalized it, and it's giving me the numbers in each bin. Where's the axis properties? There they are. So remember, there was that's how Excel was, not printing these out at 90 is because they were so tiny compared to 2,000. And when you do the full data set, you'll get 10 times this number. You'll get 20,000 here, and there'll be 100 here, and you just can't see them. So the way you can see them is by making a log scale. So you go to Y, and you click log. I'm actually hoping that it just automatically updates, but it's not. I don't know why. But I'm gonna change this to 1. And this to you're supposed to put in 10,000 here or 100,000. Anyway, we're getting kind of tiny numbers. I don't know what. Maybe it's 1 less 0. Log scale. There we go. We're starting to get some. At least it's updating. I'm trying to figure. It's still doing linear scale. I'm very confused. It's why is it? There we go. Now we got the log scale working. I don't know why log scale wasn't working. So, what's happened here is, let's look at these numbers. 5 times 10 to the 0. 5, that's just 5. 10 to the 0 is 1. So you can see that 10 to the 0 is 1. 5 times 10 to the 0 is 5. 10 to the 1 is just 10. So this is 1, 5, 10, 50. See how it's not a linear scale? That's what you want. You want it to be a logarithmic scale. Now notice what's happening here to the numbers. They're off the scale because I need to make this a little bit more. Do another 0 there. Now it looks actually really good. So as a log scale, sure, there's 1,000 of these events, right? But that you can also see kind of maybe there's a bump down here somewhere in the 90s. Maybe there's a bump down here somewhere in the 90s, because this all looks like flat now. In fact, the Epsilon Meson has kind of disappeared with this log scale. But this is the graph that will show you a clear bump somewhere over here. Somewhere between 70 and 110, there's a clear bump. Now you can't actually claim, I don't think you could make a claim there's a clear bump. Maybe there's one here at 65. Maybe there's one here at 80 87. It's hard to tell. So use the full data set, and you'll be interested to see that you have found a noticeable bump because you've used a lot more data. You have a lot more, and then look up and try to figure out what that particle is. So you just, the mass here, the units are GeV. So let's say I wanted to find out the epsilon meson was like 9 GeV. So the way you would type in like particle, what particle, well, there you go, I did this last time, has mass 10 GeV. And epsilon meson has a 9.486 GeV. So the units are GeV. They're not, so again, particle physics, we don't use kilograms or grams. It's just not the way it's just a notation. We could have been doing grams like pennies, like we did in the first example, but again, it's particle physics, so we have new units. They like to create things. So come in here and see if you can figure this out. Use the full data set. That's your exercise for the week. That is, by the way, how they found the Higgs boson. So, like, the Atlas Higgs boson histogram. Atlas is the name of the one of the experiments on the Large Hadron Collider. So here's CMS. So CMS is another experiment. There's a bump here in the histogram, right around 125, which is what it was supposed to be. I'm looking for the Atlas one. There's an Atlas one. So there's a different experiment. Ooh, it's hard to see this, but what if I click on it? It'll take me to some crazy website, right? I don't know what it's doing, but this is the Atlas one. Here's another So Atlas is a different experiment, and it sees a bump there. When they came out and declared that they had discovered this particle, they were collaborating. The Atlas team was collaborating with the CMS team. You need to have more than one person discover something, right? You have to have multiple experiments with different tools independently discovering the same thing before you can call it a discovery for sure, right? Like if you did a scientific paper in Mr. Enrique's classroom and said, oh, hey, I've discovered a new force. Look at this data, there's got to be a new force. People would be interested, but they would, scrutinize you and be skeptical unless they could reproduce it. Maybe you could reproduce it or in some other place with new equipment. More credence to you. Sure, you're going to have that. But what if a separate team using completely independent methods also found your force? Now it's a discovery, right? And since you found it first, you get the name. They'll name it after you. All right. Anyway, so yeah, good luck finding the particle. Have fun, you guys. High five.